So let's see now what is the next, which is the Wheatstone's breach. So definitely this is a very important. So it is arrangement of 4 resistance used to determine one of these unknown resistance. Yeah. So in terms of remaining 3. So how we are going to do it exactly? So let's say this is how the circuit it looks like that. So let the total current supplied by the circuit is I, then it has been that I1, I2, and again this Ig which I have shown over here. So the remaining current. So this is how we have just shown the distribution of current over here. Okay, so what we can do over here, so for this circuit, so you have to just write down those equations here. So we can just do this. So what you have to do, you have to just make sure that there is no value of current. Yeah, so there is no current which is going to flow through this your galvanometer. Yeah, so which will balance that breach. Yeah, so definitely it will make sure that the breach is going to balanced over here. Okay, so how we are going to just do that? So just according to the current, so this is plus minus, so obviously this is plus minus, so this is plus minus, and again this is plus minus. Okay, so now when we say that, so there is no current flow through this circuit, Ig is equals to 0. So let's say this one, I assume that, so the values of your resistance, that is a P, Q, R, S here. So this is, or simple, you can write it down. Let's say I am writing that R1, R2. Yes, so this is R3 and this is R4. So how we can write it down? Simple, that is a minus I1, R1. Yeah, now similarly for the first loop, which is the ABDA. Yeah, so you can consider that loop ABDA. So that is a minus I1 R1, then again plus I2 R3 plus I2 R3 is equals to 0. So this I1 R1 is equals to I2 R3. This is your first equation. Now similarly for the second case, obviously there is no flow of that Ig is 0. So then similarly that is a minus I1 R2 and then again plus I2 R4 is equals to 0. So this one I1 R2 is equals to I2 R4. That is your second equation. So just take the ratio of these two equations. So you will get that R1 by R2, yeah, is equals to R3 by, yes, so definitely again that R1 by R2 is equals to R3 by R4. So this is what we called as a Wheatstone's breach condition. So this is what we can call as R1 by R2 is equals to R3 by R4. If this is the condition which has been satisfied, then there is no current which is going to flow through that your branch, yeah, which consists of your galvanometer, and the breach is balanced. So that is what we can call as a balancing condition. Yeah, so definitely we can say that. So this is a Wheatstone's breach. So it's said to be sensitive if shows a large deflection even in the galvanometer for a small change in the resistance in the resistance arm. Yeah, and we know that again the sensitivity of Wheatstone's breach, yeah, so that depends on the two factors. So it depends on the magnitude of resistance and the position of battery and galvanometer.